Hello everyone, this is Stas and welcome to my new Touch Designer tutorial, and today I want to show you different ways how you could visualize Kinect skeleton data. And by skeleton data I mean this Kinect job with all different joints detected by the Kinect device. And I know that many folks uses Kinect and many comes to Touch Designer because of Kinect visualization and Kinect interactive capabilities. So that's why I'm gonna do this tutorial. Let me explain how it would be organized, because maybe it will be a bit lengthy tutorial. So I'm gonna do everything from scratch for one particular joint, and then if you want you could copy paste the same code for every other joint, because there is a lot of joints. But also I will share with everyone these three components. This is the main components for visualize different kind of visualization of a skeleton. It will be shared somewhere, links would be below. And here with orange color I have different visualization examples, how you could use this data, because there is unlimited possibilities of how could you use joints as points, joints as lines and metaballs. And this is just examples that I'm gonna share with my Patreon supporters. And by the way, thanks for my Patreon supporters, especially for those who support me for a long time and chose the annual subscription. And I could do all of these tutorials for you for almost 2 years now. Okay, that's enough for the words, and let's start. And first of all, I'm gonna explain to you how am I usually working with the Kinect, because here of course you could set up your Kinect, turn it on and start working, but it's not very convenient, because then you would need to stand up, move a little bit, then check how it looks, and this is not super handy. So the way I'm doing is I'm using the Kinect Studio. If you install your Kinect drivers, you have this Kinect Studio application. It comes with Kinect SDK. So you run a Kinect Studio. Here I'm running it already. And in the record page, you could record a little bit of your Kinect data, and then you could open existing file with pre-recorded. Here is my record. I'm actually sitting on it. Sitting right now, not moving, but here's my recorded data, and I could select a little bit length of this data, and I like to set the count very high, like 909, and play. And what it does, it plays this like 20 seconds cut almost like 1000 times, and the Touch Designer thinks that it's a really Kinect device that providing this data. And it's also providing, if you check this, you could check here what you want to provide. For example, do you need the color camera, or depth data, the sensor telemetry, and so on. So it depends. Usually I'm just leaving everything turned on. And the files could be quite heavy, so I'm usually record a little bit of it. But it's super useful, especially when you do some Kinect installation in some other space. So you could go to this other space, record same data, and then work in your home or in your workplace with pre-recorded data of a skeleton and point clouds and everything. So, and that's the way how I'm using it. So, either turn on now your Kinect or turn on this Kinect Studio, And also I prefer to smooth the data a little bit. I'm using here a lag with default lag settings. You could also instead use filter chop to also smooth the data. I prefer lag, it's a little bit faster and it's very good option for the default smoothing. And now let me feed this data to a new container. And the first and the most easy way of visualizing skeleton would be making a points. Let me now separate my screen view. Here's the example I made before with visualizing all the points. And that's how you could do it. You could select one joint using the select, for example, I would use the head. Okay, now I have a head and I prefer to use chop 2, and it gives you a warning because there is no such a channel, so you could pick all the channels or use the expression txyz and the brackets, and now you have a point. Maybe it's invisible, so you could turn on display option, pick this data and press home. And here is my point. And you could repeat all of this for every joint. The other way, and that's what I did here. The other way of doing this, and maybe you think it's better, is to select all the necessary channels, shuffle them with sequence and channels with n value equals 3, because we have 3 channels, X, Y, and Z. So now we have for every joint we have 3 samples, X, Y, and Z. And then you use another shuffle to swap between channels and samples. And now you have well, it's not a heap, it's tx data for every joints. This is the ty data for every joints and tz. And then you could use the same chop 2 and you'll have this skeleton. The problem with that is that sometimes, and quite often actually, I don't want to visualize all joints. For example, I usually don't use the hand tips. Sometimes I don't use wrists, the foots, and so on. And the other reason, if you see, sometimes there is some blinks. Oh, here it is. And here's one more, and here it is. So there is some glitches if you use such an approach. And this is much more stable, and but more beneficial for me is that you could turn off and turn on it easily. And I prefer to do it this way, like I have a left side of a body, a right side of a body, and the central part. And I could turn on, turn off easily. Here's my arms and here's my legs. And I send it to output. Alright, and this is the simplest possible visualization where you use just a points for every joint. But still you could do something with this. For example, and I'll share this example with my Patreon supporters, but I'll explain to everyone how to do it. This is super simple. I use this input data with all of my joints. Let me turn this display also. Here's my skeleton. And I also made the floor. And I use the particle SOP to generate the particles from this data, and I use this floor to bounce the particles. Here on the limits page, the heat behavior is bounce on the contact. And here's the second input is the collision input. So it will bounce on the contact. Also, to make the particles, let me turn this on display. Also, to make particles with different size, I'm using the life parameter. Here I'm using swap to chop and scoping custom parameters called life. And life parameter have two values, the whole life of the particles and the remaining part of the life. Because here you could set the life expectancy, but you could also set the life variance, and so my particles would live between 2 and 4 seconds. And I'm using this method with subtract and multiply it a little bit, and in the end I have the values between 0.1 and something like 0.8 or something, and it will be the scale. So here I have geometry with a sphere, and I'm using instances with this particle as a position and this math as a scale. But also I made this GLSL material because in general, by default, the touch designer used this collide as a center, the particle center. It doesn't know the size of the particles. So by default, this particle would collide and bounce from the center. So every particle would fall one radius down into the floor, and it's not wanted behavior, so I did a small GLSL material, but GLSL it's not for this tutorial. This tutorial would be totally without GLSL, I promise you. But you could, if you have this file from my Patreon, you could dive in and check how it's done. And in the end I used the depth for the luma blur and formatting. So it's very simple. And I also visualize my Kinect depth camera. Just I can't remember why I did this, but yeah. So here I am, and here is my particles. And of course, here you could set, for example, turbulence much higher, like I don't know, let's do something ridiculous, and then it becomes totally a mess. So maybe not so ridiculous, but here you could go for, it's a quite abstract right now, and person almost invisible. It's some abstract bouncing balls. Or you could turn off the turbulence and have much more readable silhouette. And I prefer to use the smaller turbulence on a Y channel because I have the gravity -3, and I don't want a lot of particles going upward because I want them mostly falling down, but a little bit of turbulence. Okay, and yeah, this is only one way of visualizing this kind of data, but let's go on to second one, join two lines. Okay, the setup is pretty similar, and let me show it with one joint. Okay, if we have head, let's have next joint, which is neck, and I use the line, and we have the 2 points, 2 ends of this line. So I just reference or export this data to the first point and next data to the second point. And let me also turn on display for the points. And here is the joint between the head and the neck. Okay. And sometimes it's good enough, but sometimes you would like to have a different number of points in this line, and then you could change the number of points. The only disadvantage of manually setting the number of points is that some, if you go into these channels, some joints, for example, going from where is it? Here is it. Going from hip to knee, it's a very long joint, while other going from wrist to hand, it's pretty short. So probably you don't want the same amount of points in every joint. And there is no simple solution to deal with it. The way I'm using it, I'm doing this in the parent component. I have this custom parameter called unit multiplicator, and when it's set to 0, we multiply it. Oh, let me show it here. For example, here I have this parameter, unit mult, and let me do it. So I use 2 default points plus 2 or some other numbers multiplied by this value. And now I could use this constant to increase or decrease. By default, when it's 0, it's just 2 points in every joint. If I increase, I should increase by the whole number. If I increase, I get more points, like 5, yeah. And I have 12 points. And what you could do with this, you could check, you could set a different numbers. For example, here for my arm, I have 2 plus 2. For a thigh, I have 2 plus 4 multiplied. For a neck, where is my neck? I have 2 plus 2. For a chest, 2 plus 4. And somewhere I also have 2 by 5, I think. What is this? This is a shoulder triangle, hip triangle. Okay, by 3, and I think you get it. Here's 5. It's between shoulders. It's a shoulder triangle, and this, the most widest part, I decided to multiply by 5. So, how to set this number, how to pick this number, I don't know. There is, I'm using some kind of drawing articles about how the typical human body is scaled. If you Google it, like human body drawing scale, something like this, you will get this, a lot of different instructions For example, which to pick? For example, this one, it gives us like a different measures of a typical child body, female body, male body, or somewhere I have it. I found the same with a relative to the head, or here is a relative to the head, how much heads in arm, how much heads in thing, and so on. So I used kind of these numbers to multiplicate these values. And what it gives me is, let me switch. Let me display all the points, and if I set unit multiplicator to, for example, 3, I have more or less evenly distributed points. The other way of doing this is you could use resample tool with setting the length or the maximum segments, but in this setup I prefer to use the way I showed to you. Also what I did is a consolidation, because if we took, for example, okay, here my arm with 2 segments, and let me switch off. Let me pause. Okay, here's my arm. But as you could probably see, maybe not, there is not a 3 points, but a 4 points, because we have one line from here, like, so we have 1, 2 points, and one line here, so is a 3rd point and a 4th point. Sometimes you want it, sometimes you would prefer to have only 1 point here. And that's why I'm having a consolidate. And consolidate SOP, and I'm using facet SOP for doing this consolidation. Here you have consolidate options. By default I'm using no consolidate, so I have 2 points in every joint, almost in every joint. For example, here I have 1 point, here I have 2 points, and so on. And if I want to consolidate, I could pick here or here on my container consolidate points fast and the consolidation distance. And usually a small distance is good enough, and it's consolidating. And now I have 17 points. If I turn off consolidation, I have 36 points. And also you could experiment with a bigger consolidation value, like, well, this is too big, and have some very abstract skeleton. But I don't see any reason to do this. So that's it for the lines, and let's check how you could use it. And I have 2 examples for using lines. Let's start from, let me turn off to keep my FPS in the sane. Let me, here I have. Okay, what's going on here? Here's my input for the lines. Could scale it a little bit if I want to, and mainly I'm using this primitive, and for scaling in primitive I'm using this parameter which scales the lines, but it scales this from the center. It scales this from the center because the pivot point is a primitive center, so it scales every line from its center, and sometimes it gives you a very interesting look. maybe you would like to see not not this 3D skeleton. It's not really easy to understand, but this, for example, 2D skeleton, and you could experiment with this. It just gives you a lot of lines, a different visualization style. If you would like to have more abstract view, more abstract visualization, this is interesting option. Another way, if here I have the silhouette using the trace, and you should use it very carefully because it's cooking very slowly, this trace SOPs. Here I using usually info for the cook time and trail to understand how much I'm using my CPU. And now I'm in between 4 and 8 milliseconds, which is okay. And then I'm converting this trace to SOP and then to limit, so I have these lines. And by default lines goes like this, and then I'm using the primitive SOP to again scale it and to rotate it probably. No, here as I'm rotating it just here. And have the different scenario for the lines. Okay. But this is a little bit different kind of lines. It uses not the chop data, but the silhouette data. All right. This one uses the real data that we just created. It uses the skeleton, and it converts it then to chop and then to SOP and creates a feedback loop. And I have a full tutorial about this kind of setup for the trails made in top operators. And I leave a link somewhere above and below and in the description. And also there is a very good Etagen tutorial about how to make, because my tutorial is about how to make instances, individual instances from these trails, and Etagen tutorial shows you how to make the tubes from it. And here I have tubes. So, and this is actually very, let me turn this on, and this is a good time to show you the difference between unit multiplicator. Now I have such a look, and if I set unit multiplicator to, for example, 10, the look would be very different. By some strange reason, it doesn't work right now. Oh, because, yeah, that's it. Because this trail SOP, it usually needs for a feedback working properly, it needs the same amount of number of points. And here I have a different number of points every time. So what you could do with this, if I check off the consolidate, it becomes stable. So that's why did it work, and it's good that I have this bug on my tutorial, because now I could show you why it could be broken. Because consolidation, it changes the number of points, so it becomes unstable, and for some visualization like this one, it's crucial to have a stable, the same amount of points every frame. So it's not this flag. And here I have different settings with a different visualization, but it's not a topic of this tutorial because I have a separate tutorial about this way of making trails. What I wanted to show you is that the number of units really matters and creates a very different look between 2 points per segment or a lot of points per segment. Okay, that's it for the lines, and let's go next to this metaballs. And I will show it. For example, a result from this is this shiny man. The metaballs are very heavy, so if you don't have a very powerful GPU, probably it would be, well, let's see how much is it. Well, not super heavy, but yeah, quite a heavy. Okay, what do you need to do it? How could you do this? Go inside, pick a line, and let me now switch number of points a little bit lower, like 3. Now I have 8 points. Let me. And I pick the metaball. I want it quite small. And I use copy operator, copy, and copy metaball to all points in my line. And here I have a different looking metaball, and it also depends on metaball kernel function and all these values. I prefer for the most of the segments used either link or Boolean model. And let me switch. This is the neck example, so it's kind of short. Maybe 3, maybe. So you need to experiment with these values and different models. Well, not variable, blend. So either links or Boolean works. Okay. And then you repeat it for all of your segments. But the way I'm doing this, in my opinion, all extremities, you would like to have one setting for all of your for both of your arms and legs, or probably maybe you need to have a separate 2 metaballs, one for the arms and one for the legs. With one settings of metaball, I have separate settings for the metaball. For my head, it's only head joint, and a separate one for my torso, which is shoulder, spine, and hip. And here I have a segment for this 3 and another metaball. And as an output, I have this man puppet. And also I have this some custom parameters to tweak it inside the container and not to go inside. And I could really change the way it looks by switching between it. Okay. What else you could do with metaball next? Of course, you could render it as it is, like this smooth man. Or let's also go inside here. Or you could use the facet. You could use the facet and use unique points and compute normals. And it didn't work because you need first to convert it. And convert this model to polygon. And now it works fine. And instead of smooth man, you have this faceted man like in my example here. This is shiny man. And let me also switch back to the links. Another way you could do this is, instead of faceting, you could use the wireframe and visualize it like this wireframed man. Or you could do some other stuff, for example, use the line material and visualize in normals, and then you will have, well, now you need to switch back to facet, and you have this shiny man with pointy normals. Maybe you would like to have it by some reason, or very pointy. Also, it's not a 4, of course, but maybe you like this kind of aesthetics, so you could go on and use it. Alright. Shiny man closed. And mostly that's it. This is the main part of the tutorial, and two couple more examples. Now I could delete this pre-made container, I could close this data. Another way, totally different way of visualizing this data would be Raymarching, and I have the long tutorial in 3 parts about Raymarching. It's like 5 hours long. It will give you an ability. Now I need to switch on this Raymarch flag. It will give you ability to create very smooth and interesting looking shapes, and using different noises and everything. Here I have my oops. Let me go it back. Here I have also displacement. I could use some different tricks with Raymarching, and it gives you a lot of different possibilities that you wouldn't have with just a SOP approach. Well. The problem with Raymarching is a totally different stuff, and you need to go and code with GLSL. And even with Kinect, of course, you could download this example and my other examples with Raymarching and Kinect Raymarching from my Patreon, but it will give you only this one particular look. While the best way of using Raymarching is to really understand how it's organized, and then you have endless possibilities of using Raymarching with different colors, different options, different noises, and everything. So if you're ready to dive into GLSL, I really recommend to also see this kind of approach. And also I want to mention some other tools made by different people in Touch Designer community, which are worth checking. One tool is a different kind of visualization lines. This very interesting looking Kinect example. It's free. It's from Xnimax, and you could I'll leave links in the descriptions. And it uses the kind of similar approach as we have here with my lines, but then he uses very interesting trick to manipulate the lines to make it these curly lines. Really worth checking how it's made, especially if you intermediate Touch Designer user, because this approach is really fun. And I haven't seen anything like this before, so it's worth understanding how it's made. If you more like puppets and models, like human models, you could also check the ninja puppet from the same guy, and this is it, and it will look like this with some extra rotating stuff. So if it's also free, so worth checking. And the third way of visualizing is to create really create a rig with bones and everything, like a proper rig, like it's done on many other applications like Blender and everything. And you could watch 2 parts of tutorials from factory settings about how making this. Personally, I don't use the Kinect rigs because from my experience it becomes very glitchy because sometimes Kinect doesn't detect all of the joints, and rig puppets don't really like when your hair, for example, your leg suddenly disappear or detected in some other direction. And also it's because I'm usually I like to visualize dances, and dance movements are very strange. This rig approach could work fine with standing, walking, swinging hands, but it's very glitchy if you move a lot, if a person near Kinect moves a lot. And as a bonus, I'm gonna show you also, I'm not diving today into point clouds in different Kinect cameras because this tutorial is about making sops, but I wanted to mention that Kinect point cloud and the Kinect the values from joints come in same coordinate system. So you could use, for example, head, like I'm did in here. Here I have a light coming from my head, and it's in the place of my head. Or for example, I could write the GLSL for this messing this point cloud data near my head, like near my head, or not so near my head, or far away. So the whole skeleton could be messed, or just my head. But as I said, it's not a topic of this tutorial. Only reason I showed it to you because it uses the data from the jobs. And by the way, I have a tutorial about Kinect point cloud and another tutorial about how you could voxelize everything. Like here, if I put this on, I have voxelized it. I could set my like voxels, not messy, but voxels in order. Okay, and this works for 3D, so point cloud and 3D. And if you want to do the same with 2D, for example with a color camera or depth camera, you need to go into Kinect, and instead of world space position, use the color space position or depth space position, and it gives you select oops oh it gives you UV channel for every of your joints, and UV channels would give you coordinates in the screen, well, in the top space. So here you would have I can't remember how UV organized in Kinect. Probably here would be 0, here would be 1, and You could place anything like circles or whatever you want from your joints up to you, either color data. I could use it because I'm already used this. Either color or depth data or player index. That's why you have the separate color space position and depth space, because the color space is this resolution, while the depth space is in different resolution. Okay, that's it for today. So now you could either do it by yourself if you like to do everything from scratch to understand it better, or download these free examples, or go to my Patreon and download everything. And that's it for today. Thank you for watching. Subscribe, hit like, leave the comments if you have any questions or suggestions, and goodbye.